Hi everyone, thank you for joining. In this video we're going to prove an inequality, an important inequality, Cauchy-Schwarz inequality. Now there are several methods to prove this. The one I'm going to use is I'm going to consider a quadratic trinomial. Now if we consider sum, I goes from 1 to n, aix minus bi squared, and if we expand that we have I goes from 1 to n, that's ai squared x squared minus 2aibix plus bi squared. And if we write it, if you expand that, we have something I goes from 1 to n, ai squared x squared minus summing 2aibix plus summing bi squared, right? Okay, so we can take x squared outside. I goes from 1 to n, ai squared minus 2x summing I goes from 1 to n, aibi plus summing I goes from 1 to n, bi squared, right? Now if you notice, this is in the form of ax squared plus bx plus c. So we have x squared there, x there, and a constant term there, right? And we know that this is equal to aix minus bi all squared. That means it will have to be greater than or equal to 0, right? In other words, this polynomial, well, this trinomial cannot be negative. Minimum value it can have is 0, and if you just consider a quadratic, it will be talking about something like it, in the limiting case, touches the axis and then moves back, or it doesn't have any roots at all. That means the discriminant of this polynomial will have to be less than or equal to 0. So discriminant is, we look at b squared minus 4ac. We have 4, open bracket, I goes from 1 to n, aibi squared, so that's our b squared, minus 4ac is minus 4, a is I goes from 1 to n, ai squared, and the c is I goes from 1 to n, bi squared, and we want this to be less than or equal to 0. And this implies that we must have I goes from 1 to n, aibi squared must be less than or equal to summing I goes from 1 to n, ai squared times bi squared, right? And this is the required inequality. Okay, well, I hope you enjoyed it. I hope you found it interesting. Thank you very much for joining, and I look forward to seeing you in my future videos. Thank you.